Hello, everyone. I'm thrilled to be with you today to launch Biomade, the new Bioindustrial Manufacturing Innovation Institute. We're here to build a sustainable domestic end-to-end ecosystem focused on bioindustrial products. Normally, I end these things with thank yous, but I want to start with some thank yous today because we wouldn't be here without a very large number of partners that we've been working with. Nearly 100 organizations have come together to build this institute. From academia, industry, and across the US government, we're here today to try to do something incredible. Bioindustrial manufacturing has an opportunity to impact all sectors of the economy, all areas of society, and only by working together are we able to do this. I want to particularly thank the US government for their leadership in recognizing the importance of this area and transitioning this technology from something that happens in laboratories and small facilities around the country to being able to enter the commercial market and impact society around us. Biomade is the bioindustrial manufacturing and design ecosystem. We're the newest Manufacturing USA Institute, and we're working together to build technologies that impact society around us. We're also working on building a workforce of the future and understanding how bioscience, bioengineering, and industrial biotechnology can impact biomanufacturing in positive ways. The initial investment of almost $90 million from the federal government and nearly twice that from the private sector puts us on strong footing to build this institute. The mission of Biomade is to enable domestic bioindustrial manufacturing at all scales, develop technologies that enhance US bioindustrial competitiveness, de-risk investment in relevant technologies, and expand the biomanufacturing workforce to realize the economic promise of industrial biomanufacturing. So what is bioindustrial manufacturing? Bioindustrial manufacturing is making chemicals and materials into the products around us using biology. Biomade is here to propel technologies from the lab scale to full-scale manufacturing. We're not here to manufacture the goods. That's what all of the companies are here to do. We're here to help those companies develop technologies in partnership with academia, in partnership with the federal government, and in partnership with Biomade to be able to make these goods in a way that is useful for those companies, for society, and for all people. The way we're going to do that is by manipulating organisms, manipulating biology to create the chemicals and materials we want. We then need to accumulate enough material, testable quantities of material, often 1 kilogram or more, to enter into commercial testing so that companies can understand the products that are entering the marketplace. To do that, you need pure enough material, so developing downstream processing technologies to diversify the opportunities in the chemical and material space, and de-risking those technologies so that a greater number of products can enter the market. Ultimately, though, to do this, we have to execute. Execute encompasses many aspects of developing biotech, all of the technology focus I've talked about, but also ensuring that the workforce of the future is there, ready to fill the jobs that are going to be created by advancing this field. Biomade is an innovation institute. The way we think about innovation is by defining the problem, discovering technologies, discovering opportunities together, developing those technologies with purpose-built, purpose-driven teams, and designing transformative approaches that can make manufacturing technologies as interesting, as exciting, as impactful as the early stage technologies that this field has often focused on. I want to take a minute to talk about how Biomade is going to actually work. Biomade, as I said, is a group of companies and universities all focused on advancing these technologies together. In many ways, Biomade is the facilitator. We help industry identify the priorities that they have. We develop a technology roadmap to focus those technologies on the most impactful areas. And then we develop project calls or requests for proposals where we ask you, the companies, the universities, to submit your best ideas to BioMADE, and then use the funding that we've been able to establish to fund that work. The work is intended to advance manufacturing technologies, and so it's important that we ultimately focus on scale up downstream processing, turning the early stage into the late stage. And that's what we want to focus on really with BioMADE, with our members, and is the core of what we'll do. We're only going to be able to develop these technologies through purpose-driven teams. Small companies working with large companies working with academic institutions working with small companies, developing regional partnerships as part of a national network. All of these mechanisms are opportunities to develop relationships across these companies, and those relationships are ultimately what is going to lead to products entering the marketplace. So I want to take a moment to talk about BioMade's approach to innovation, particularly how we understand risk and reward. An innovation institute has to take some level of risk, but it doesn't have to take infinite risk. And so for us, we've identified an 80-20 model for how we're going to make investments. I talked about the technology roadmap that we're developing. The roadmap takes an iterative approach to developing technologies. That iterative approach gives us opportunities along the way to assess how we're doing and deviate when necessary. On the other hand, iterative approaches don't always lead to the most impactful results. And so Biomade is reserving 20% of its financial resources to make investments on high-risk, high-reward work. If we have a goal 2 years from now, can we get there in 6 months? If we have a goal 10 years from now, can we get there in 2 years? We know we won't be successful every time, but if we are, those transformative innovations will have a large impact on the companies that we work with, develop IP that is really relevant to the industry, and allow us to have a step change improvement versus an iterative improvement over what we're trying to do. A few minutes ago, I talked about how we need to transition from lab scale to full commercial scale. Well, that doesn't happen on its own, and it doesn't happen in a vacuum. Over the last year developing BioMade, we heard from a large number of companies that in the US, we have an infrastructure problem. The problem is that we have great lab scale facilities. We have a reasonable amount of commercial infrastructure, very large scale infrastructure to make products that are entering the market. But the R&D infrastructure between the two is lacking. Infrastructure in the middle, pilot scale, intermediate scale infrastructure to develop that kilogram I talked about earlier, is hard to find in the US. One of Biomade's focus areas is going to be to catalyze investment in infrastructure so that companies are able to do this work from the lab scale to the pilot scale to the intermediate scale to the commercial scale, all in the US, all working in that innovation ecosystem. To start us off, Biomade's main site is on the University of Minnesota campus here in the Twin Cities. In the next couple years, we will have started up a pilot-scale biomanufacturing facility that we can use for research and development within the Biomade ecosystem, but that's also available to companies to scale up their technologies, to scale up their products by adding some pilot-scale infrastructure into the ecosystem. One facility focused on 5,000 liters is not going to be enough for the US. We know that. But it's a start, and it allows Biomade to play a role from the beginning in developing some infrastructure. That's not where this ends. We understand that we need a national network of pilot and intermediate scale infrastructure to ultimately make a dent in what we want to do with industrial biomanufacturing. We want companies to be able to access infrastructure when they need it, to be able to put products in and have them fail faster. Yes, I said fail faster because the faster you fail, the sooner you can move on to the next one, the less investment you make. And you have to have the infrastructure to do that. So Biomade is committed to working with its members to understand what is that infrastructure and how do we make that happen. I spent the last few minutes talking about innovation and technology development, but it's important to realize that Biomade as a network has power in its network effect, power as a facilitator. And so working together, we're able to impact national networks and national movement in a way that would be very hard, if not impossible, for any individual entity to do on its own. Our infrastructure philosophy, though, is important. As a member network, we're not trying to create or duplicate infrastructure that companies and universities already have. If it exists, we want it part of the network. If we don't know about it, we want to know about it. If it does exist and it belongs somewhere else, we want to know that, and we want to do our part to make that happen. Ultimately, Biomade is here to leverage its members' expertise to do things to develop bioindustrial manufacturing in the US. That's what it means to be a nonprofit public-private partnership. We're here for the members. We're here to develop these technologies, to develop this infrastructure in a way that's ultimately going to help society around us. It's not about us. It's about the companies. It's about the universities. It's about the members. And that's what we're here to facilitate and do. So I've spent some time talking about technology and infrastructure. I want to turn for a minute and talk about education and workforce development. We want to make sure that we have people available to fill the jobs of the future. The only way we're going to do that is by having an early and dedicated focus on developing that workforce so that they can fill those jobs. There are a few ways that we have to do this. First way, engagement with industry. We at Biomade aren't creating these jobs. These jobs come from the companies. And so we need to know, what do those jobs look like? What are the skills that people need to be able to fill those jobs? We then need to work with the national education networks, and our Chief Workforce Development Officer is focused on doing just that. Outreach, communication, coordination are all core tenets of Biomade's technology development ecosystem. They are also core tenets of our education and workforce development ecosystem. Understanding that we have to focus on equity, sustainability, and a long-term approach to regional and national innovation in order for those people, those jobs, to be filled by people in local communities. This is an area, when we're talking about manufacturing, a manufacturing innovation institute, where we have an opportunity to reach relatively large numbers of people from all across society. We want to make sure that the fourth grader, who really doesn't understand what manufacturing is, let alone bioindustrial manufacturing, has some understanding early on that biology is more than just about health, more than just about the trees that are outside, but that biology is a technology that can be used to manufacture goods. When they get to high school, we want them to understand what modern biotechnology looks like and how it can impact biomanufacturing and society around us. In terms of developing the workforce, we want to make sure that we are working closely with our community college partners, our university partners, our job retraining partners to make these jobs available to the widest cross-section of society possible. We're also focused on building a safe, secure, sustainable, and socially responsible innovation ecosystem that can ultimately impact society around us. Anytime we're working with biology, we need to understand that biology is part of us, and working with our colleagues to understand appropriate and inculcated bioethics, understand appropriate legal frameworks, build bridges between the US government regulators and companies so that the regulators understand the products of the future and the companies understand the expectations of the regulators. Understand the security implications of the technologies we're developing. Security is an important part of biology and biotechnology. Right now, we're living in a global pandemic, and so understanding that biology can have profound impacts on society around us is something that's incredibly important to me, incredibly important to Biomade, and is something that will be part of all of the work that we do going forward. So I've spent a few minutes telling you what Biomade is and what Biomade is going to do. Now I want to take a few minutes to tell you why you should be part of Biomade. Biomade is here to bring together academia, industry, and government to focus on advancing bioindustrial technologies. What that means is that we're here to listen. We're here to listen to the needs and opportunities that are present in the US innovation ecosystem and help build an institute that's able to focus on those needs. It's to provide an opportunity for all companies of all sizes to participate, to develop intellectual property, to develop technologies that will ultimately move many companies forward, to develop a sustainable innovation ecosystem. Sustainability in this sense means a lot of things. It means both financially sustainable as well as environmentally sustainable. It means sustainable governance. It means sustainable development. All of these aspects coming from the companies, from the universities and institutions that are part of Biomade. We're here to be inclusive and transparent so that you can come in, work with us with clear parameters and a clear understanding of what we together are trying to accomplish. By joining, you have an opportunity to submit proposals for technology development, for education and workforce development, as well as for our work in safety, security, sustainability, and social responsibility. By submitting proposals, you give us your ideas, we map them to the roadmap, and then make funding decisions to try to develop those areas that are most interesting and most impactful to the ecosystem. Membership is based on tiers. Those tiers are described in our membership materials. And we invite you to look at those, talk to us, and join Biomade to participate from the ground floor. So I started today by thanking groups of people, and I'm going to end at the same place. Biomade is about the nearly 100 partners that worked with us over the last year to develop the ideas that I am privileged to talk to you about today. From industry to academia to government, all of these partners have come together to understand our opportunity to advance bioindustrial manufacturing in the US. Starting with the leadership from the US Department of Defense and the federal government, working with companies large and small, we have an opportunity to really make a difference and advance bioindustrial manufacturing from a small number of products to a large number of products that we would like to see throughout society today. 6 months ago, we issued a press release announcing that Biomade had been selected to create this Manufacturing Innovation Institute. Over the last 6 months, an incredibly hardworking staff at Biomade has gotten us from that point to where we are today so that we're able to open our doors to you, sign up members, and get to work. Today's launch is the beginning of that opportunity. You're going to hear today from a number of our partners, from the leadership of Biomade, about different specific aspects that we're going to focus on. We look forward to building Biomade and bioindustrial manufacturing together, and I look forward to working with you over the next months and years to ultimately make Biomade a successful bioindustrial manufacturing innovation institute. Biomade is headquartered on the campus of the University of Minnesota. Here to introduce their role in hosting Biomade is President Joan Gabel.
Hello, I'm Joan Gabel, President of the University of Minnesota, and the university is proud to be home to the new major manufacturing institute, Biomade. I want to thank DoD for this transformational commitment and everyone responsible across our university community for advancing this innovative work, which is poised to catalyze our national landscape. As a top 10 $1 billion public research enterprise, the University of Minnesota is uniquely positioned to leverage this important new partnership. We've developed a national reputation in biomanufacturing over the last 3 decades, and our already thriving life science and med tech industries squarely position Minnesota to serve as a leading national bio-based manufacturing hub, attracting world-class talent, driving high-tech innovation, and creating dynamic new startups and jobs. DoD's important investment will also rapidly revolutionize our industrial biomanufacturing ecosystem, advancing the current work of our university researchers and the nation's private sector. In particular, this initiative will help to bridge the gap between young firms with cutting-edge expertise and well-established companies that use biomanufacturing methods to make smaller numbers of compounds and materials at a very large scale. It will also help build an end-to-end ecosystem spanning the industrial biomanufacturing spectrum, supporting collaborative projects that will help younger firms to more easily pilot and scale up their work, and legacy firms to broaden and diversify the compounds and materials they produce. I'm excited about how all of this aligns with the university's focus on discovery, innovation, and impact through MPACT 2025, our new system-wide strategic plan, and more particularly, how our work enhances opportunities for new businesses and startups, corporate partnerships, and tech commercialization. DoD has recognized the University of Minnesota's existing strengths, and the opportunities for our economy and our workforce are enormous. According to the McKinsey Global Institute, the emerging bioeconomy is estimated to have a $2 to $4 trillion direct economic impact annually across the globe within 20 years. With Biomade, the University of Minnesota is at the forefront of this transformational promise, modeling the mid-1980s transformation of Austin, Texas, as a high-tech center after it was awarded a DoD grant to advance semiconductor manufacturing, and the development of Pittsburgh, Pennsylvania, where the National Robotics Engineering Lab at Carnegie Mellon University is catalyzing an economy of robotics innovation. Friends, the bio-revolution is here, and Biomade will ensure that the University of Minnesota and our nation are driving innovative solutions to ensure the prosperity and security of all Americans and beyond.
Thank you, President Gabel, for the remarks. Biomade is a member-driven institute. To introduce and highlight some of our diverse membership, we have created a series of short recorded discussions with business leaders, scientists, engineers, and educators that we're calling Faces of Biomade. Here is our Interim Chief Technology Officer, Steve Evans, who will host the first Faces of Biomade.
Hi, my name is Steve Evans, and I'm the Interim Chief Technology Officer at Biomed. I'm here today with Emily and Zach, two pioneers in the industrial biotechnology community. Today, we will be discussing how innovations in material performance and the re-envisioning of supply chains for biotechnology are creating a new and exciting future. Hi, Emily. It's great to have you here. My first question for you is that the word biotechnology and even the phrase supply chain, they're increasingly appearing together in the news and the headlines. So what role does Twist play now in the biotech manufacturing supply chain? And how do you see Twist and Biomade strengthening domestic bioindustrial supply chains for resiliency in the future?
Thanks, Steve. That's a great question. Indeed, Twist is part of the supply chain. We provide the DNA, we provide the raw material that is used for the discovery of new materials and discovery of new organisms that produce those materials. And COVID has put quite a bit of a strain on the supply chain. On one end, it's great that we're able to, as an industry, develop and build vaccines in about a year, but there's a lot of material that has gone to COVID that is not available to the rest of the biotech industry. So what we do at Twist is, fortunately, because we miniaturize the synthesis of our DNA, we actually don't have as much need for supply chain as maybe other suppliers. which means that we can make sure that the DNA that our customers need to do their research and development is available. And then in addition, what we are doing is, to increase the geographic diversity, we are opening a second site in Portland. So we'll have 2 locations from which we can make DNA, which will increase business continuity and make sure that the customers that rely on what we build are never disrupted.
Thanks, Emily. That was great. And congratulations on opening that second supply site domestically. That's very good news. So, Zach, I'm also excited to see you again today. And, a lot of people, when they think about biomanufacturing, they think about it as being something that's more sustainable or carbon neutral, or maybe generally better for the environment. But that may miss the point that some of the bioproducts may have demonstrable performance advantages. Could you tell us a little bit about Zymergen's new product, Highline, and the impact that you expect it to have?
Thanks, Steve. Good question. I think this is a really important point that most people underappreciate, which is that biology not only offers us sustainability, but also access to performance features based on the chemistries available to us through biology that may not be readily accessible through any other means. Highline, which is the first product we launched recently, is a very good example of this. It is a film that we intend to use in flexible displays and monitors that has extraordinary physical and optical properties that have been impossible to attain through the use of traditional synthetic chemistry methods. It's fundamentally the incorporation of special biomolecules that we identified that give the material its astonishing properties and make it desirable by our customers. They certainly appreciate the sustainability, but the real reason they're after it is because it has performance that they can't get any other way. And ultimately, I see that the rise of the bioeconomy will happen much more quickly if we can capitalize upon the advantages of biology, not just for sustainability, but for performance enhancements as well. So ultimately, the way Zymergen sees it is sustainability is very important and firmly in the passenger seat, while performance is in the driver's seat. Promoting the bioeconomy through superior products is the fastest route to its onset from our perspective.
Thanks, Zach. I really like that illustration of the driver's seat and the passenger seat. I think that's a great way to cast this. So I've got one final question for both of you. If you look at the changes that have occurred over the past 5 years or so in biology as it is a manufacturing science, what excites you the most about the prospects for the next 5 years of using biology to manufacture? Zach, maybe if you can go first.
What excites me most is the prospect of treating the manufacturing form as a rapid response to unmet customer needs. So rather than focusing on the production of a large volume molecule with diverse applications, we can actually capitalize upon the speed and flexibility of biomanufacturing, or biofacturing as we call it at Zymergen, to tailor make specific molecules chosen to address the particular performance need that is unmet in the market today. When I began in the industry 10 or 15 years ago, there was a paradigm of each company in this space would pursue a single target molecule intending to generate huge volumes and markets from it. Basically a form of business that was inspired by what has been historically true in the petroleum industry. And what we actually see that biology enables is the ability to custom make molecules chosen for their particular niche application and bring them to market much more quickly and much more inexpensively than has historically been possible. And I think ultimately will cause a renaissance in material science and application sciences as we have all this molecular diversity to draw upon.
Thanks, Zach. That's a great story about blending biology with material science. So Emily, what excites you about the next 5 years?
I think that's a great question. And I think to me, what excites me over the next 5 years is the acceleration of the transition from petroleum-based product to a biomanufactured product. I think the last 100 years have been the century of plastic, and the next 100 years can be the century of proteins and biomaterials. And we are right at the beginning of that. Plastics have been amazing to our lifestyle, but they're not sustainable. And to build on what Zach said earlier, by switching to protein or manufactured material, we'll get either an economic benefit where the material is going to be cheaper, or it's going to be better, and we'll get sustainability for free. But definitely that the vast potential of new materials that we'll be able to enjoy in the rest of our lifetime is going to be great. There's been very little innovation in the chemical industry in the last 10, 20 years because they've just tried everything that can be made by chemistry. But with biology, a lot more is going to be available, and as a result, there'll be, I think, an increase in the workforce for bioeconomy, and the bioeconomy will employ a vast number of people, and that's going to be a huge benefit to society and to the environment.
Emily, that was a great tie-in to the workforce, and I really appreciate hearing your vision of a 100-year look forward and the role you're trying to play in it. So I thank you both for your contributions.
Thank you, Steve.
Thanks, Steve.
The next group of speakers features the Biomed leadership team, who have been working hard to lay the foundation for the Institute's technology, education, and social responsibility missions. First up is Steve Evans again, who will go into more detail on Biomade's technical mission.
One of our core values is innovation catalyzed by collaboration. And we bring together over 100 institutions from across the private industry spectrum, from academia, nonprofits, and from diverse government groups. Manufacturing with biology is poised to deliver on core needs for new materials having better performance properties, or for making things with a less impactful environmental footprint. So it is not enough just to discover new biosynthesis routes or new capabilities if we cannot put these to work. We must marshal the science, engineering, and technology needed to put biology to work, making things in new ways, even in ways we have yet to imagine. Biomade will identify and lower barriers to making new materials with new biology. We use the core value of collaboration to blend technology with real needs driven by extensive industry input so that we can explore new ways to make biology more impactful. We must focus both on technology and on economics. Biomade is uniquely poised to catalyze activity at this interface so that as we continue to decrease technology risks, we are in parallel decreasing economic risks in taking biomanufacturing to the next scale. We will partner to create robust supply chains that may not even be in existence today, to impact both sustainability and security. At Biomade, we understand people are increasingly interested in compelling materials with novel properties. They increasingly seek processes with advantaged footprints for sustainability and social responsibility. A key to helping us realize the potential of biomanufacturing with biology is developing a national biomanufacturing technology roadmap. With input from across the technology ecosystem, the Biomade roadmap will inform our committees and working groups and will be the framework on which we develop and execute compelling collaborative projects. For technology teams, work that is safe, secure, sustainable, and socially responsible is not just a slogan. It is a commitment to a way of life. We hope you too are excited about this opportunity, and we invite you to join us in our mission to enable domestic bioindustrial manufacturing at scale, in de-risking technologies to enhance domestic competitiveness, in right-sizing our nation's biomanufacturing infrastructure, and in creating an engaged, informed, and prepared workforce for the future. Thank you for your attention and your interest in Biomed.
Thanks, Steve. Next up is Tom Tuban, our Chief Workforce Development Officer. Tom is the newest member of the Biomed leadership team and will tell you about his plans to educate and train a strong workforce to support bioindustrial manufacturing.
It is a distinct honor to serve Biomaid as we launch the 16th Manufacturing Innovation Institute, the 9th supported under the Department of Defense. Moving forward, our focus and resolve is on the development of an end-to-end ecosystem for domestic manufacturing to secure America's future through manufacturing, education, and collaboration. The efforts to support modernization and the development of technical innovation and biotechnology are foundational to the mission of Biomade's education and workforce development strategic plans. Our vision is to prepare a robust domestic workforce for manufacturing jobs across the industry. The education and workforce development approach is sharply focused on the Department of Defense and industry drivers that emphasize community awareness and engagement, product innovation, development, commercialization, and economic security. This will require an all-hands-on-deck approach to coordinate all partners in the Biomed ecosystem, including our existing military assets, business and industries, institutes of higher education, research-intensive universities, community and technical colleges, and professional societies and trade organizations. Importantly, we will invest in the future and plant the seed for strong career pathways for bioindustrial manufacturing through our secondary schools, as they represent the next generation of our nation's scientists and engineers. Our vision for Biomade's workforce development and education initiatives are built on 3 primary guiding principles. First, we emphasize the importance of membership-driven strategic partnerships. We value contributions from industry, academia, government agencies, and community-based organizations, and leverage this information to produce a unified and collective strategy to identify what exists, adapt what is successful, and create what is needed. As we move forward with this important and foundational landscaping and road mapping, we will ensure that the growth and prosperity of our bioindustrial manufacturing industries remain a top priority. Second, we focus on efficient and effective workforce program development. To accomplish this, Biomed will adopt successful conventional approaches to workforce readiness and education and support existing training programs in addition to seeking novel, proactive strategies developed around core skills and competencies that are specific to the bioindustrial manufacturing sector. This will require direct engagement of our members and expansion of efforts to include industry-directed experience-based learning, flexible delivery modes, and workforce training, education, and certification, such as face-to-face instruction, hybrid, and online distance learning modalities. Third, our education and workforce development efforts are committed to addressing the ethical, legal, and social implications as part of the fabric of Biomed. Our activities will be designed to seamlessly integrate principles and measurable outcomes related to diversity, equity, inclusion, and accessibility across all areas of bioindustrial manufacturing. This places a specific focus on our education and workforce development efforts to define career pathways, engage our community, and expand the talent pool to create an inclusive workforce fueled by diversity of thought that lead to innovation and progress and economic security for our nation's science and engineering enterprise. I am excited to be part of the effort as we launch Biomade's strategic plan for education and workforce development. As Chief Workforce Development Officer, I'm committed to work tirelessly alongside all of you to build strong strategic partnerships, develop a unified community of practice for education and workforce development, and advance product development and commercialization through the presence of a highly prepared, diverse, and inclusive technical workforce. I want to thank everyone who has joined us today to celebrate our launch. I look forward to working with you as we collectively build the Biomed workforce ecosystem. Thank you.
That was great, Tom. Now Altacharo, who is chairing our 4S committee focused on safety, security, sustainability, and social impact, will speak to us about those efforts.
Safe, secure, sustainable, and socially responsible. That's the Biomade commitment. Safety goes beyond following federal regulations and looking to improve the experience for workers, starting with their training and moving into the workplace itself, always looking for better ways to maintain worker safety, product quality, and environmental safety for the general public. And security. Of course, a core commitment for each Biomade member and for Biomade overall is to make sure that both information and materials are managed in ways that maximize benefit but minimize the risk of accidental or intentional misuse that might result in a danger to human health, to animal health, or the environment. Sustainable. Bioengineering can be an enormous asset when it comes to providing foods that are nutritious and grown in ways that require far less of a carbon footprint. Food that can be grown in ways that is more adaptable to a changing climate. And yet, the public often misunderstands the safety and the value of this kind of engineering. One of Biomade's commitments is to engage with the public and address their concerns before those concerns become obstacles to developing new products that would help us all. It's socially responsible. All too often, new inventions, new products, new processes are simply out of reach for most people. They're too expensive, they're too difficult to use, they're not provided in their local neighborhoods, or they're simply not designed with a broad range of people in mind. Biomade's commitment to socially responsible bioengineering is a commitment to thinking about these things in advance, anticipating the fullest range of uses, looking for those that could be improved by some change in order to make them of greater benefit to the broader population, looking for ways to make sure that they're not misused or mishandled in ways that make them inaccessible to the broader population. Safety, security, sustainability, and social responsibility. It's a commitment that Biomade is making to itself, to its members, and to the country. And it's part and parcel of how we become more competitive and more effective as a country and as an industry. I'm Altacharo. I'll be working with Gigi Granval and Dave Shepard to help introduce a new unit within Biomade that will help our members to adapt these ideas to their own settings and provide advice and guidance and develop standards that we would expect all members to meet so that this commitment can be fulfilled. Thank you.
Another round of thanks to the Biomade leadership team, who have been working hard on this launch and making sure that we are ready to run on all cylinders starting today. Before we transition to a group of speakers representing different government agencies, we're going to run another Faces of Biomade episode where the Biomade Government Chief Technology Officer, Jimmy Golahar, sits down with members from national labs and armed forces research centers.
Hi, I'm Jimmy Golahar, the Government CTO of Biomade. In this segment of Faces of Biomade, we will be speaking with scientists from national and service labs. Welcome everyone, thank you for joining me. Deepti, can you tell us a bit about your home organization and how you use biotechnology?
Hi, I'm here today to represent the Advanced Biofuels and Bioproducts Process Development Unit, which is a part of the Lawrence Berkeley National Lab. We are funded by Department of Energy Bioenergy Technologies Office to help scale up synthetic biology-based technologies from industry and academia. We have worked with over 65 companies so far, and we've produced prototype materials and scaled their technologies from milliliters to hundreds of liters scale. As a part of Biomade, we want to continue that work and also help support collaborative research that will resolve some pre-competitive problems in this space.
Thanks. As a follow-up, how can Biomade best serve a connected bioeconomy?
I really do think Biomade can have a significant impact in this space because many small companies are facing similar problems, but they are not incentivized to solve these problems for themselves. Biomade can come to bring these companies together and solve these pre-competitive problems and accelerate the pace of commercialization for these technologies.
Thanks, Deepti. Peter, what are some unique challenges that you feel Biomade will overcome to produce the largest impact on bioindustrial manufacturing?
Thank you, Jimmy. I really appreciate the opportunity to talk about Biomade because we're really passionate about it. At the end of the day, the complexity of actually scaling up predictably at scale is very challenging, and bringing the best of the nation to bear on that problem is really going to help us increase the efficiency so that we can really harvest the value proposition of biomanufacturing and synthetic biology. And I'm really excited what Biomade can bring to the table for that.
Fantastic. Thank you, Peter. Dasha, how do you envision your organization working with Biomeg?
I envision my organization will serve a exploratory site of new ideas, which will be later delivered to Biomade for scale-up manufacturing. I'm also excited about working in the educational and workforce development area. And I want to introduce our students and trainees to the unique research projects that are going on and how they can meet future U.S. Navy and Marine Corps needs and operations.
Thanks, Dasha. Nancy, how do you envision your organization working with Biomade?
Thank you, Jimmy. Really a pleasure to be here for Biomade's kickoff and to represent the Air Force. We really do see that the Air Force Research Lab has been one of the leading organizations that has helped to create Biomade. At the grassroots stage, AFRL helped to define its scope, provide contract support. We also feel like we will continue to enable and shape its success. Biomade, we do feel, is a unique resource in the U.S. for the U.S., and we look for opportunities to deliver capabilities to our warfighter through Biomade. Our team is dedicated to the synergy of Biomade. Bringing together the components of this initiative will help us to achieve more than one organization can do on its own. Some of those components are the digital backbone as well as the workforce development. We see these are key things that will really move us forward to allow biotech to deliver technologies. Thank you.
Thanks everyone for joining us today. It was great to hear from all of the service labs and ABPDU. We're really looking forward to building Biomade together.
Thank you, Jimmy, and the members who participated in that discussion. Here is Tom Vilsack, the U.S. Secretary of Agriculture, to say some words about the ties between Biomade and domestic agriculture.
Thank you for allowing me to share some opening remarks for your meeting and the launch of the Biomade initiative. Climate change is a significant challenge for our health, for our food supply, and to our national security as a nation. I applaud your discussions today about ways to better incorporate the use of bio-based products and fuels into our broader marketplace and our national security infrastructure. The plan also addresses the climate crisis with a market-based approach and begins to move us toward a clean energy economy led by production of renewable fuel and energy and bio-based products grown and manufactured here in the United States. This is an opportunity to create thousands of new jobs right here at home. In my last tenure as Secretary of Agriculture, a top priority for me was to work with the Department of Defense on the development of a drop-in advanced biofuel for marine application. It's a proud day in 2016 when I stood with Secretary of the Navy Ray Mabus on the deck of a ship being filled with biofuel produced from feedstocks in rural America. The deployment of the USS John C. Stennis Carrier Strike Group as part of the Green Fleet was an important first step during that administration. We know that bio-based products make sense for applications such as the military. Quite frankly, sourcing raw materials such as petroleum and extracted minerals from other locations around the globe is not only expensive and time-consuming, but the very movement of these materials is challenging from a national security standpoint. Advances in science mean that biomanufactured products can be just as good or superior to those from traditional raw materials. And best of all, the revenue generated from those products goes to farmers and foresters and communities across rural America. Now the Biomade project has the potential to take many further next steps towards realizing the promise that biomanufacturing offers. Virtually any manufactured good that can be imagined can be created and sourced from plant materials and other available biological building blocks. Everything from buildings to body armor to containers to aviation components can all be made better, stronger, and cheaper using the right biological know-how. As I understand, this group is going to be putting thought and research into the potential applications and mapping of a pathway to increase this effort. As you do, please know that USDA and its research capability and partnership with universities and the land grant system is a resource and a partner. And keep our American farmers in mind. American farmers can grow crops better than anyone and have repeatedly exhibited better yields and better quality than anywhere else in the world. With the Climate Smart Agriculture effort USDA is launching, American farmers will lead on sustainably produced food and bio-based materials while conserving soil and water and reducing greenhouse gases. The potential is there to create a massive win for rural America and farmers, a massive win for the end users of these goods, and a massive win for sustainability and the conservation footprint of all of us collectively. Thank you in advance for all that you'll achieve to expand the thinking and building of the capacity for bio-based manufacturing. USDA and the Biden administration look forward to supporting efforts to create jobs and to address climate change and support a bio-based manufacturing revolution in rural America.
Thanks, Tom. Next, Stephanie Rogers, the Principal Director for Biotechnology at the Office of the Undersecretary of Defense for Research and Engineering, will tell us why she is excited about Biomade.
Hello, I'm very excited to be a part of this day, the virtual launch of Biomade. I'm Dr. Stephanie Rogers, Acting Principal Director of Biotechnology at the Department of Defense in the Office of the Undersecretary for Research and Engineering. In support of the National Defense Strategy, DoD has 11 modernization priorities, each led by a Principal Director, who's responsible for defining the strategy and roadmaps to advance these priority areas and unifying and advancing the department's investments and capabilities. We view biotechnology as a technical discipline that enables the engineering of biological systems and processes to produce a wide range of technologies and products, as well as utilizing biological data to enable rapid technological advances. Engineering biology allows us to produce an enormous range of products, from foods and medicines to textiles and fuels. And it's estimated that over the next 10 to 20 years, biotechnology could create approximately up to $4 trillion of direct annual economic impact, and that doesn't account for downstream and secondary effects. What is clear is that the nation that leads the world in biotechnology will accrue enduring economic, societal, and defense gains. For DoD, biotechnology has the potential to fundamentally change the future battlefield and warfighter capabilities. This includes building new materials for military systems, enabling new methods for sensing and monitoring, augmenting performance and protecting the warfighter from harsh environments, and building resilience to evolving threats. An application that is particularly exciting is the use of biotechnology to produce mission-critical materials without relying on fragile supply chains. To realize the full potential impact of biotechnology, DoD must move from basic and applied research toward laboratory prototypes and reliable and reproducible manufacturing at scale. It is not sufficient to just have DoD capacity and infrastructure. There must also be robust, reliable, and secure U.S. capacity and infrastructure. We must do this together, the DoD, the interagency and its allies and partners, and the broader U.S. at large. Together, we aim to advance domestic biomanufacturing through innovative technologies for scale-up, prototyping, testing, and evaluation to support the establishment and growth of supply chain intermediaries within the U.S. that are essential for the bioeconomy. Modernization will not only depend on capacity and infrastructure, but will also depend on fostering a world-class, diverse, and multidisciplinary workforce, on sharing and leveraging fundamental knowledge and toolkits with academia, industry, and international allies and partners, and becoming a global leader in responsible use of biotechnology to drive norms and standards. We believe that a department modernized in biotechnology drives innovation and rapid translation of new knowledge to applications.
and it will accomplish this through effectively partnering with a U.S. ecosystem that is also modernized in biotechnology. And that brings us to the stand-up of Biomade. This stand-up of the 9th DoD Manufacturing Innovation Institute is an inflection point. It coincides with and serves as a response to a national agenda to capitalize on and advance biotechnology and biomanufacturing. President Biden's executive order, America's Supply Chain, calls for resilient, diverse, and secure supply chains to ensure our economic prosperity and national security, to revitalize and rebuild domestic manufacturing capacity. President Biden's American Jobs Plan calls for revitalizing manufacturing, securing U.S. supply chains, investing in R&D, and training Americans for the jobs of the future. The Interim National Security Strategic Guidance establishes the goal of doubling down on science and technology investments, including domestic leading-edge manufacturing, to enable the pursuit of numerous national strategic objectives. And there are numerous initiatives across the interagency that bolster this national agenda and aim to support the bioeconomy, advance biotechnology, and move the needle in domestic biomanufacturing. Biomade is well poised to catalyze the biomanufacturing ecosystem and help bring this vision into reality to address national needs. We are excited in R&E biotech modernization to collaborate with such a great ecosystem of partners across government, industry, and academia. Congratulations, Biomade, on your opening day.
Thank you for those comments, Stephanie. In our next Faces of Biomade segment, Michael Smansky, the Deputy Chief Technology Officer for Biomade, will talk with representatives from some of our academic members and discuss the technologies that underlie bioindustrial manufacturing.
Hello, my name is Mike Smansky. I'm the Deputy Chief Technical Officer of Biomade. Today, I have the opportunity to sit down with a few scientists and engineers who are representing some of the academic members of Biomade. We'll get this opportunity to nerd out a little bit on the technical area in which Biomade is going to be focused. Hi everybody, thanks for joining me. Chris, I would like to start with you. You've been a prominent voice in synthetic biology in the past 2 decades. Can you sum up how we arrived at the place we are now and what you think needs to be done in the next 20 years?
The last 20 years have been enormously successful in terms of making cells that can do things, whether it be a chemical that's being produced or where the cell is being made as a therapeutic. The whole challenge has been making enough of it. So it's the curse of the black dust, where you can make a very small amount of whatever it is you're trying to make, but if you need a kilogram in order to actually go test something about that material, going from the proof of principle of engineering a cell to getting the scale up and the levels of production that you need to actually demonstrate utility to move it forward has been very difficult. And this is a new form of the valley of death in terms of projects, where you see all these wonderful papers, but no way to realize what they actually enable.
Thanks, Chris. That was great. Michelle, most bioindustrial manufacturing today uses a small set of microbes, for example, baker's yeast. One priority identified in our technical roadmap is onboarding or domesticating new types of microorganisms that have special capabilities. Can you tell us about your work in this area?
Sure. I think that synthetic biology and biomanufacturing can really benefit from unusual microbes that we find in so-called extreme environments. And in particular, as an example, a lot of bioconversion processes rely on the action of enzymes, which you can think of as little micro machines that perform a lot of the chemical transformations that we want to scale up. And some of the most valuable enzymes come from microbes that have not really been domesticated, and we don't really know how to wield and let alone use and adopt for biomanufacturing. part of how our group is addressing this is to source microorganisms that come from large herbivores, which are really good at chomping what we'll call the non-food part of plant biomass into bite-sized bits of sugars. And we really want to enrich and isolate the microorganisms that are doing those jobs, and also to just learn what the enzymes are so that we can manufacture those enzymes and use them to turn substrates like plant waste into something that's value added.
Thanks, Michelle. That was great. Hui-Min, your lab also works with some non-standard microbes. What special traits do the strains your group develops bring to the table?
Yeah, indeed, my lab has been exploring various non-model organisms for biomanufacturing. For example, we are engineering Escherichia orientalis for production of organic acids such as 3-HP, succinic acid, and muconic acid. And this organic acid can be used for making nylon 6,6 and also like the materials in diapers. So we decided to work with Escherichia orientalis, mainly because they work on the low pH, which can greatly simplify the production purification of the organic acids to reduce the production costs.
Thanks, Hui-Min. Pamela, moving to you, one of the big step changes in the past 20 years is the complex decision-making that can be engineered into microorganisms. Part of that work includes giving these organisms the ability to sense and respond to new molecules. What are biosensors, and what role can they play in bioindustrial manufacturing?
So today we can design millions of strains in a couple of hours. We can build thousands of strains in a couple of days. What really limits the engineering of chemical producing microbes is how fast we can test them. So if your compound is not colorimetric or fluorescent using existing technology, it takes between 5 to 30 minutes to just evaluate a single chemical producing microbe. That puts you screening at about 300 microbes per day. What our lab does is engineers high throughput biosensors that allow detecting the bioproducts straight in the microbial broth. So the sensors that we build screen at a rate of about 1 compound per second. So we can test about 86,000 compounds per day. If you couple this with microfluidics, you can screen about 10 million samples per day. This is really a game-changing technology because it allows you to much faster engineer microbes for chemical bioproduction. And additionally, the microbes could be integrated into the final production stream. That is, the sensor could sense the fermenter environment and give this information back to the microbe that can go and upregulate or downregulate transporters or signaling pathways to maintain an optimal biosynthetic productivity in the fermenter throughout the world.
That's great. I think there's a lot of potential when we start integrating those complex traits into our fermenter producing organisms. Finally, Chris, I'll throw it back to you for the last question. What do you see as the future for bioindustrial manufacturing?
I think we're going to have to move beyond carbon-based products. So there's been a real sense out there that what you need to be able to do is engineer a pathway that can create any molecule of interest. Like here's a molecule, now how do we build a cell to make that molecule? And we're ignoring 100 years of chemistry as we do that process. Some molecules make a lot more sense to be produced using chemistry. There are some specialized functions that are really appropriate for biology. And moving to the future, we're going to have to understand how to take the best of both worlds, marry them together, so that if there's a compound that we need to be able to make, we can incorporate the best chemistry, the best biology towards that process. So biomanufacturing can't be viewed alone. It has to be integrated with chemical manufacturing.
Thanks, Chris. That's a great way to wrap up this talk. And thank you all, panelists, for joining us on this episode of Faces with Biomade. I look forward to working with you in the future.
Congrats, Biomade. Can't wait to get started.
Now, Congressman John Garamendi from California, chair of the Readiness Subcommittee of House Armed Services, will join us to say a few words.
April 28th. April 28th is going to be remembered for many, many years because it is the kickoff of BioMADE. This is going to be really, really important to the future, not only of American manufacturing, but really to the world, because we're looking at how to replace petroleum chemicals with natural chemicals and materials made in the biological area. It's really important that we do this, not just because it's an enormous opportunity for America to advance its manufacturing and to develop all kinds of materials, from fuels that are made from biology to synthetic materials. It is going to be important as we pursue this. You can just imagine most everything we do today comes from the chemical world, the petroleum chemicals. Doesn't have to be that way. We can shift. In California, my district in California, which I call the Biological Research Center, where there's pharmaceuticals or materials, the corridor I-80, all the way from Sacramento to the Bay Area, is the heart of this innovation. And so Biomade, you're going to be important because it's not just California, it's not just my district, but it also is the rest of America. We can lead. We don't have to depend upon the Chinese. We can do it in America. We can make it in America, and you're going to be the leader on that. So congratulations to all of you. I'm excited, as you can tell, and I'm sure you're even more excited about the future opportunities that are going to be there as we transition from the laboratory and the research to the actual manufacturing. So go for it. Biomade, Biomade all the way.
Steve Grove is the Minnesota Commissioner of Employment and Economic Development. He will discuss the importance of BioMADE in nucleating job growth in bioindustrial manufacturing.
Good afternoon, everybody. I'm Steve Grove, the Commissioner of the Department of Employment and Economic Development. And on behalf of Governor Tim Walz, Lieutenant Governor Peggy Flanagan, and the entire state of Minnesota, I want to congratulate BioMADE on its launch day and say how tremendously proud and excited we are to have BioMADE here in Minnesota, housed on the St. Paul campus of the University of Minnesota. This is a remarkable opportunity for the Twin Cities and Minnesota to become the hub for bioindustrial manufacturing. And at the risk of sounding a little bold, a little immodestly un-Minnesotan, we really think this is the perfect place to launch this effort. That's because this is just a state of problem solvers. It always has been. This is a state full of naturally curious people who build practical things that improve people's lives. We've got an entrepreneurial mindset here that imagines better ways to do things. You couple that with a Midwestern work ethic that never says it can't be done, and we think we're a great place for this effort and are proud to host it. Because of top-notch educational institutions like the University of Minnesota, we have the talent and expertise here to succeed in this work. But we have something else that's just as critical. We have a collaborative culture in which business and academia and state government really work closely together. They've done so for many years. We have seen that trend on hyperdrive this last year throughout the COVID-19 pandemic. This is a state where sectors work together to make change and to build prosperity. For our state, this means businesses are supporting a wide range of programs and companies of all sizes. We here at DEED are committed to promoting innovative startups and helping them establish businesses and helping others grow and relocate here through our programs. We've got a lot to help companies find employees, train their workforce, new skills and technologies, and expand their facilities and export their products abroad as well. So we are a committed partner in this effort. We've invested in the infrastructure that enables businesses to keep supply chains moving and get your products to market. Along with the broadband infrastructure that's vital to operating our businesses today, whether you're a manufacturer in Mankato or a farmer in Faribault, that broadband is so critical and a part of our efforts to help our state's economy grow. You know, Minnesota's long been a leader in bioscience and agriculture with companies like Cargill, CHS, General Mills, Land O'Lakes, Hormel Foods, among many others. And this really helps ensure we have the business infrastructure that will make BioMade thrive. We want to thank the Department of Defense for selecting our state and the University of Minnesota for this very special initiative, and say that we believe you will be very glad that you did. So again, thrilled to welcome the launch of BioMade, looking forward to working very closely with all of the companies that come out of it and to help them take their new bioproducts and technologies to the next level. Thanks, everybody.
For the next Faces of BioMADE episode, Seth Thompson, a Biomade program manager for education and workforce development sits down for a conversation with educators to discuss training the next generation of biotech workers.
Hi everyone, I'm Seth Thompson, an Education and Workforce Development Program Manager for Biomade. On today's Faces of Biomade panel, I'll be talking with some of our members about the important role Biomade will play in catalyzing innovative education and workforce development programs. We've brought together an impressive group of experts covering the full range of workforce activities Biomade will engage in. Welcome everyone. Thanks for taking the time to join us on this call today. I'm excited for our conversation, and I want to start with a question for Natalie. As the founder and executive director of BioBuilder Education Foundation, you've been on the forefront of bringing biotechnology education to the future generation of the workforce. Building broader awareness of the career paths in bioindustrial manufacturing will be a key focus of Biomade. How can Biomade promote efforts that will inspire young people to pursue careers in bioindustrial manufacturing?
Well, thanks, Seth. I think the answer is actually embedded there in the question. You talk about inspiring young people. That is such a key feature of what we will need to do to bring individuals into industrial biomanufacturing. We currently teach biology as a collection of facts to be memorized and somehow make the idea that that's attractive to people to become scientists and engineers. In fact, biology now is becoming a substrate for engineering, and we can bring people in with all their creativity and all their inspirations at really quite young ages to be able to design with biology. In BioBuilder, we see that this actually accomplishes two things. First is that it helps students see a place for themselves in this endeavor, this career. It also trains them in a way that gives them a leg up in their pursuit of these kinds of college and career pathways.
Awesome, thanks. In addition to building national awareness, Biomade will also support world-class training to prepare a skilled and agile bioindustrial manufacturing workforce. Russ, as the Executive Director for the National Center for the Biotechnology Workforce, you spent over 15 years supporting workforce development in biotechnology. What can Biomade learn from this history of workforce development across biotechnology, and how can we take that learning and adapt it to the specific needs of bioindustrial manufacturing?
Seth, it's a delight to be here today with Biomade, and I think your questions are really pertinent. You know, I had a long industry record before I came to the academic side of things or the workforce side of things. And so I'm very, very close to industry, and I've never really lost that closeness. And so one of the things that I really have learned through the 15 years of working on this side, the workforce side, is the word collaboration. And I think it's extremely important that companies and industry and academics learn how to work closely together. By doing so, we get a better product, and we get a product that answers a need. So collaboration is one of the very first things that I think about. The second thing I think about really is staying close to your customer. Biomade will have to define its ecosystem, and as it defines its ecosystem, it'll have to figure out, which customers they're going to have to be very close to and very, very in tune with their needs from a workforce perspective. This leads me to a skill discussion, which actually is, at the end of the day, what we really need to focus on. We need to understand what those skills are that the people are going to need that are going to move into this aspect of industry. We already know a lot about that, but we have to be able to get those to decipher those skills. So what we've learned over 15 years is the skills are constantly being upgraded and changed. And I would say to Biomade, being very close to your customer, really understanding the technological changes and being able to keep abreast of those through constant dialogue is the way to go. We have noticed in our own grants that we have through the National Science Foundation and working very collaboratively with our partners across the country that, the industry works at its speed, the institutions work at their speed, but if they're dialoguing, then both are moving at a good progress point. In summary, I think it's really, being close to the customer, understanding the skill differentiation. Technology is rapidly advancing, so we really need to be on top of that.
Great, let's continue to build on that idea. Lene, you've been the Center of Technical Training in Biotechnology for more than 2 decades now. As the director of Innovate Bioeducation Center, you've advanced technical programs across an impressive network of community and technical colleges. How can Biomade coordinate its efforts to include bioindustrial specific training into these existing programs of Innovate Bio members?
So as you indicated, Innovate Bio primarily focuses on technician education. However, we do pay attention to the entire career pathway, as many of our alumni over the 25 years that these centers have existed that are funded by NSF have continued their education and progressed up the career ladder. That being said, to ensure that our primary audience, which is the 2-year biotechnology programs at community colleges, can update their curriculum to meet the needs of the workforce, we spend quite a bit of time determining what are the emerging trends in biotech and then translating that into workforce trends. Innovate Bio views Biomade as key in the bioindustrial area. There's absolutely no way Innovate Bio can do all of the areas of biotechnology. And with Biomade's help and with Innovate Bio's help, we'll be able to meet that need. For example, one thing we do is that Biomade is able to do project calls, which Innovate Bio cannot do. And I can envision that these project calls could be encompassing some of what are the emerging trends in industry that will be translated into workforce. Then committees could be formed to essentially determine what are the changes in educational needs, essentially, so that then they can be translated into programs. The project calls could cover also the fact that curriculum needs to be developed. One thing I do emphasize is that we don't want to have curriculum such that we have to make new courses all the time, because as we all know, institutional requirements and approval take time. So one thing Biomade can help with our membership and our community is to focus on modularizing curriculum and updating essentially the skills within that established curriculum, so institutional requirements are not essentially changed. And then you don't have to get approval from the institutions, and changes can be made very rapidly. So in a nutshell, if we together work on identifying emerging workforce trends, changes in skills, and then work together to update curriculum that's been modularized, so it'll be easy to rapidly change the curriculum and the education for technicians, as well as other levels within that career pathway. Together, Innovate Bio and Biomade can essentially keep abreast of all the changes that are occurring in that industry.
Great, thank you, Linnea. Thank you so much for that insight. Lastly, I want to talk a little bit about how we can integrate efforts across the technical and workforce development efforts of Biomade. Brent, you're a professor at Iowa State University and director of the NSF-funded Engineering Research Center for Biorenewable Chemicals. How can Biomade's research-intensive universities play a key role in integrating efforts across the technical programs and education and workforce development efforts of Biomade?
Yeah, thanks, Seth. When we look at advancing bioindustrial manufacturing, we're really looking at the intersection between biotechnology and processing. And that introduces new technology research questions, such as how do we optimize microbes and fermenters? How do we integrate those with downstream processing? And so we need a workforce that understands these new technological questions and area and the opportunities and constraints created by it. So Biomeg creates an ecosystem that allows us to integrate those new technology discoveries and understandings with the robust educational infrastructure that you've heard from our previous panelists, with the goal then that we can overall create this workforce that's needed for this new bioindustrial manufacturing technology space.
Great, thank you so much. With that, we'll wrap our conversation on today's Faces of Biomade panel. I want to thank all of our panelists for their wonderful insights, and I look forward to working with all of our Biomade members to support the mission of delivering innovative education and workforce development programs across the Biomade ecosystem.
As I mentioned earlier, Biomade is headquartered at the University of Minnesota. There will be satellite offices in the Bay Area and Boston. In our last segment today, you will hear from leadership at these host sites. First is Valerie Forbes, Dean of the College of Biological Sciences at the University of Minnesota.
Thank you for the introduction, Doug, and thank you for the invitation to participate in the Biomed Launch event. As the Dean of the College of Biological Sciences, where we study all aspects of life, I can't help but make a biology analogy. You see, back in October, when the Department of Defense selected Biomade to be its newest manufacturing innovation institute, there was a brief period of celebration with announcements and press releases. That was Biomade's conception. Then things went quiet for a few months. As the dean, I got a lot of questions, and I'm sure Doug and the government program management team did as well. What is happening with Biomade? When will we hear more? Well, that was the gestation period. And while it may have seemed quiet from the outside, I can assure you that there was a lot going on behind the scenes. And in what I have come to learn is the normal breakneck speed of DoD initiatives. Here we are, after just a 6-month gestation period, coming together to celebrate Biomade's birth. So, happy birthday, Biomade. Your future is bright, and we look forward to helping you grow, mature, and reproduce for many years to come. I'd like to use my time today to tell you about the multiple ways in which the College of Biological Sciences is going to work with Biomade to advance its mission. First and foremost is physical infrastructure. Very early on, when Biomade was learning from its members that lack of pilot-scale infrastructure was a major limitation for the field, the opportunity for synergism between CBS and Biomade became clear. Our college had also realized that there were opportunities to grow our physical infrastructure for biomanufacturing, and we were already moving forward with plans to construct a new pilot-scale plant for our Biotechnology Resource Center. With the Biomade partnership, we've expanded those plans and are adding a second floor to the new building that will house both under one roof. We're excited that this will provide opportunities to complement each other's capabilities and strengths to offer the community a one-stop shop for testing pilot-scale biomanufacturing processes up to 5,000 liters. Our college also offers a comprehensive array of core facilities for genomics, proteomics, metabolomics, and material testing. These resources can be leveraged by members of the Biomade community to complement capabilities present within their own organizations. Related to Biomade's education and workforce development mission, our college has a first-of-its-kind Department of Biology Teaching and Learning that develops evidence-based learning materials and practices. We have state-of-the-art active learning classrooms and teaching labs that can be a part of the workforce training activities happening under the Biomade umbrella. Biomade is an industry-focused innovation center with a national reach. We at CBS are excited about the prospect of Biomade catalyzing a change in the way that major research universities like the University of Minnesota interact and engage with private companies and national labs. There are things that each sector does really well, and by creating stronger ties, we can build a robust and resilient network, the proverbial rising tide that lifts all boats. In this way, the University of Minnesota and the College of Biological Sciences is excited to work with Biomade to create a new template for how industry and academia interact. The new building that will house Biomade will be the cornerstone of a new biotechnology research quadrant on the St. Paul campus. In building out the quadrant, we're going to bring down some silos, both literally and figuratively. The siloing off of industry versus academia, which many graduate students see as a bifurcation that will set their career path, doesn't need to be that way. Working with Biomade, we in the College of Biological Sciences are excited to create a new template for industry-academia interactions. We can strengthen the ties between industry and academia in a way that preserves both industry interests and academic freedoms while maximizing innovation. Our aim is to be leaders in this regard, to showcase a new system of private-public partnerships that can be replicated in major research universities around the nation. We will share the things that work and improve the things that don't. What emerges will be a new model for what it means to be an innovation center. I want to thank all of you watching today for joining to help us celebrate the birth of Biomade. It is a day for celebration, but there is a lot of work ahead. I want to reiterate something that you have heard already today, and I am sure you will hear again. Biomade will succeed because of the strength of its members. We owe a debt of gratitude to the companies, universities, community colleges, and nonprofits that have worked with Biomade and the University of Minnesota for the past 16 months to bring us here. And I look forward to working with you all to grow this tremendously exciting biomanufacturing ecosystem.
Thanks for those encouraging remarks, Valerie. Next, we'll hear from Carol Christ, Chancellor of the University of California at Berkeley.
Hello, and thank you for this wonderful opportunity to participate in the launch day for the Bioindustrial Manufacturing and Design ecosystem in collaboration with leaders from the US government, industry, and academia. UC Berkeley is excited to participate in this major institute and to support Biomade in building a new and significant bioindustrial manufacturing innovation ecosystem. Since the dawn of civilization, humans have used biotechnology to make useful tools and products. Today, a rapid convergence of technologies and new discoveries allows us to harness the power of the cell in the growing field of industrial-scale biomanufacturing. According to a recent National Academies report, the value of the US bioeconomy is thriving at nearly $1 trillion annually, and by some estimates, it is expected to become a $4 trillion annual industry worldwide over the next 10 to 20 years. By bringing together government, academia, industry, and nonprofit organizations, Biomade will harness the most creative science and the most innovative technologies to develop solutions for the challenges associated with bioindustrial manufacturing. Biomade will be a major growth engine of the US economy. UC Berkeley has a long history of innovative research and groundbreaking discovery in engineering biology, synthetic biology, genetic engineering, automation, computational sciences, process engineering, and material sciences. But the collective strength of Biomade's outstanding membership will enable and accelerate even greater impact by helping to span the valley of death between lab-scale technological advances and corporate investment in at-scale manufacturing technologies. Biomade will support collaborative interdisciplinary teams to solve hard problems and will provide incentives for collaboration between academia and industry. I'm especially pleased that Biomade has committed to incorporating ethical, legal, and social implications into all projects, and that members will work alongside experts in bioethics, biosecurity, and biosafety. It's so important to ensure that scientific and technological advances serve the interests of a diverse society. UC Berkeley is proud to be part of this initiative, and looks forward to working with other partner organizations to accelerate biotechnology modernization and the development of this field that's so critical to strengthening our nation's competitiveness, security, and prosperity. Congratulations, and thank you to the Biomade team. We're honored to work with such dedicated and innovative colleagues. May the things we learn through Biomade light the way to a better future.
Now we will hear from the chair of the University of Minnesota Board of Regents, Ken Powell, who has a unique perspective both as a regent and as the former head of General Mills, a company in the biomanufacturing space.
Hello, I'm Ken Powell, chair of the University of Minnesota Board of Regents, and greetings on behalf of my fellow regents and the entire university community. This is a tremendously exciting day for all of us. I want to start by thanking the Department of Defense for their substantial investment in the Biomade Institute and for their participation in today's launch event. I really do look forward to the time when we can welcome you in person to our beautiful Twin Cities campus. I first learned about the possibility of bringing Biomade to our university last summer, and I was thrilled. I would say that this is one of the most exciting initiatives to come before the board during my tenure. Before I retired in 2017, I enjoyed a long career at General Mills, eventually serving as the chairman and CEO from 2007 to 2017. General Mills is a Fortune 500 company and a worldwide leader in manufacturing and delivering bio-based food products to consumers around the world. With that experience and perspective, I think the timing and focus of this investment from the Department of Defense is exceptionally good. Biomade promises to provide more sustainable, biological solutions to manufacturing the things that we use every day, and it will do that by bringing together some of the best minds in industry and the university. And that collaboration will lead to innovation, new products, economic, and job growth. The University of Minnesota is thrilled to be the host for Biomade, and we look forward to seeing the Institute reach its goals for advancing the bioeconomy. And I hope you see the board's approval of this partnership and related development on our St. Paul campus as this university's support at the very highest levels. We'll continue to explore ways to build stronger ties with large and small companies across the nation, both to drive research innovation and to build a strong workforce. And finally, I want to welcome all the current and future members of the Biomade Institute to the University of Minnesota, and I look forward to greeting all of you in person very soon. The group of companies, universities, and nonprofits behind Biomade is impressive, and by continuing to work together, I have no doubt that we will achieve great things. Thanks to every single one of you.
Thanks, Ken, for those insightful comments. We're going to wrap up with one last Faces of Biomade before our closing remarks. Once again, this segment will highlight some of our industry member organizations and how these companies will interact to move the ecosystem forward.
Hi, this is Steve Evans again. This segment of Faces of Biomade will once again feature some of our industry members. The discussion will be led by Clem Fortman, the Biomade lead program manager, who is joining us remotely along with our panelists. Clem, I'll hand this over to you now.
All right. Thanks, Steve. Today, I'm joined by Paul Hill, Vice President of Process Development and Engineering at Amyris, and Tim Gardner, CEO and founder of Riffin, two of the industry members of Biomade. They're here to talk to us about how Biomade can help propel bioindustrial manufacturing in the U.S. So I'll start with Paul. Paul, Amyris was one of the first companies to use high throughput robotics and data analytics to do strain construction and high throughput screening. How can this technology be applied to move things up to and past the pilot scale?
Thanks for the question, Clem. And it's been great to be able to participate with the Biomade Coalition. Amyris has been aggressive at taking products to full-scale manufacturing relatively early in the product development cycle. This is in part because of the excellence of the R&D team, who, as you know, pioneered the industrialization of synthetic biology through massive investments in automation, computing, and the application of great science, but also a significant investment in process development. We've been able to create scalable, robust, and sustainable manufacturing processes for a growing array of different molecules, and then rapidly transfer them to full-scale manufacturing facilities around the world. So in this way, we've been able to successfully commercialize 13 different molecules over the past decade or so. And so to specifically answer your question, because of the speed of the strain engineering team and the nimbleness of the process development approach, we're able to not only create strains enabling commercially relevant fermentation performance quickly, but additionally continue to develop the strains, the fermentation process, and the downstream purification technology in tandem, even after that initial piloting and commercialization. So this enables us to both get to the pilot scale, but also that full manufacturing scale quickly, in addition to enabling reductions in manufacturing costs and improvements in sustainability metrics as the commercial demand for the products grows.
Thanks, Paul. Tim, building on that, this whole field is generating a lot of data and is reliant on that data to move things forward faster. As a data company focused on engineering biology, you get to see a lot of data management systems from across the industry. How can Biomade help develop and propagate standards that will be best practice for this industry?
One of the most fundamental challenges I think we have in data and the use of data for faster product and process development is our understanding of it, our relationship to it. So my experiences in 20 years of R&D as a practitioner, as opposed to my current role, which is now developing software to support R&D. In those first 20 years, I found that people would often think of data as an afterthought. It's all about the experiment, the equipment, the hardware, etc. I gather some data, I can just assume that data is going to be usable, trustworthy, etc. And then it'll answer my questions and I can do the next experiment. But the truth is you get out of anything what you put into it. And if you don't pay attention to how you collect the data, its quality, how it's going to come together to answer questions at the end of your experiment, then you actually don't get a very good set of data. One of the lessons I learned when I was in Amherst working with Paul as a colleague was the extraordinary power that data has to accelerate your work if you treat it well. Amherst does a remarkable job of it. And I felt that the rest of the industry was lagging behind and that they needed the tool sets to make that more accessible, more in the sense of easier to achieve that kind of data and process quality. And that meant tools. It also meant standardizing, to your point, the way we shape that data, how we collect it, how it's stored, how process attributes and process structures that reflect that data, how they are shared, and the data that comes out of our data systems for use. And that's really where we're focused. It's only one piece of the bigger puzzle of Biomade, of faster and more reliable process development, but it's an important one that we're really excited to contribute to.
Building on that, how do you see Biomade utilizing the data captured from disparate sources and disparate projects, working that data together and still protecting the proprietary interests of the members?
Data security is very achievable. When we built our own software, we wrote our first security document before we wrote our first line of code. So in a sense, it's a cultural thing. If you take it as part and parcel of the data equation, it becomes a very manageable thing, and manageable without restricting your use.
That's great. I really look forward to utilizing your lessons learned to help us maintain a secure and productive information pool and pipeline. Paul, Amherst is one of the most successful bioindustrial manufacturing companies to come online in the last 20 years. How can you utilize Biomade and our ecosystem of members to help you move new products and processes forward faster?
Yeah, one thing we've been learning, especially over the last few years, as we brought more products to market, is that this approach to fermentation, strain development, synthetic biology, this technology is enabling the fermentation production of entirely new classes of useful, sustainably produced molecules. So, how do we collectively, as an ecosystem in the U.S., move more of these products to market faster? From my perspective, I see two big opportunities. There have been a few cases in the last few years, and whereas in as little as 6 months, the Amyris strain engineering team has been able to deliver a production-ready organism that enables us to meet our commercial targets. And while that was amazing, and certainly not this way for every target, this speed does put a lot of pressure on the process development team. And so as we look at more targets coming that might be on that type of timetable, we need to be able to develop a combination of better predictive models for bio-based processes, more high throughput experimentation for acquiring essential data, and more efficient systems for organizing and mining process data across all scales, from microtiter plates to the manufacturing scale. Some of the things that Tim has been talking about and developing. Further, many of these new to fermentation molecules will require new technology development to be able to enable different approaches to fermentation, downstream processing, and the intersection of the two. So, when I think about Biomade and our participation with Biomade, I think with the support of Biomade, the tools and technology developed around these ideas, and as well, there are many other good ideas brought forward by the diverse members of the Biomade coalition. I think the support of Biomade would enable all Biomade members to benefit from more rapidly advance their products through the development of this type of technology. And lastly, I would just add that Amyris is relatively matured into terms of some of the companies that might participate in Biomade, and there may be some that are just bringing their first product to market. So, I think I would add that separate and apart from that, the piloting capabilities being designed into the Biomade facility in Minnesota will be an amazing resources, both to Amyris, more established companies, and to these newer companies that are bringing that first.
Tim, Paul, thank you both for joining me today. We and the rest of the Biomade team very much look forward to working with both of you and your teams to move this industry forward faster as we stand up and get going on a wide array of projects. Thank you both.
Thank you for joining us today for the Biomed Launch. We're excited to open our doors to create a domestic ecosystem focused on advancing bioindustrial manufacturing technologies. It took a lot of work to get to this point, but we are only at the beginning. Together with the help of strong membership of companies, universities, community colleges, and nonprofits, and in collaboration with the US government, we're excited to work with all of you to lead the country and the world to the future of manufacturing.